So we're about to go over homework, and this is 4th period. We're going to go over homework, and so 7th period, I'm going to let you see what we found out or what we looked at when we were going over homework, since I can't be there to go over homework with you. But 4th period would like to say hi.
Hi! We love you, half a neck, even though you're half a neck.
All right, so first one that was asked for, a number, and this is in all of the problems that were asked for. We're in the assignment for 10.3. I didn't get any questions from the one for 10.4. The first one I was asked for is problem number 13, and this would be on page 259. It says the table shows the distance of an elevator from the ground floor at different times. Right here, graph the data and show the rates of change. Well, these are specific points, so this is going to be a discrete graph. So when I graph this, I would graph it as a discrete graph. When the time is 0, let's see, this is the highest this is going to go is 70. So I might go by tens. 60, 70, 80. So this is by tens. And this would be 50. And on time, we need to go from 0 to 35. So I think I'll go maybe by 5s. Let me 2, 3, 4. Okay, so this is by 5s. So this would be 10, 20, 30, 40. So when the time is 0, the distance from the ground floor is 30 meters. So that's right here. When the time is 15, the distance from the ground floor is 70 meters. So that would be right up here. When the time is 23, the distance from the ground floor is 0 meters. So that's right here. When the time is 45, I'm sorry. Well, hang on. Shh. Let the. Shh. 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 Can y'all stop talking, please? Okay. Then the when the time is 30, the distance is 45. And when the time is 60, when the time is 35, the distance is 60. So yes, I did say it was discrete, but we're going to actually be looking at these rates of change, so I'm going to go ahead and connect them. I'm sorry. It's really not a, well, I don't know. It really doesn't matter whether you consider it continuous or discrete, as long as you know that you're looking for rates of change. So I went ahead and connected them. Okay, so graph the data and show the rates of change. So the rate of change from 0.30 to 1570 is the change in the independent variable over the change, the change in the dependent on top, change in the independent on the bottom. So the rate of change from here to here would be 70 minus 30, which is 40, over 15 minus 0. So the first rate of change is, let's call this A to B, is 40 over 15, or 8 over 3. Okay, so that's from A to B. This is very much like the ski slope problem from yesterday, or the ski lift problem. From B to C here, and C is at 23.0. From B to C, the rate of change is 0 minus 70, which is negative 70, over 23 minus 15, which is 8. And that simplifies to negative 35 fourths. I think that's all you can do on that one. The rate of change from C to D should be positive again. So this time we are going from 23.0 to 30/45. 30/45. So it's 45 minus 0 over 30 minus 23. That can't be simplified. And last but not least, from D to E, we have 60 minus 45 over 35 minus 30, and that's 3. So those are your rates of change from one point to the next point for each one of these. And I guess it makes sense to connect these just so that you can see that we're like basically finding the slope of a line. I wouldn't really worry about whether it's connected or not. I don't really care if it's connected or not. But what you're graphing is really individual points, so that's why I said it was discrete, but I wasn't thinking forward to what we're going to do with it when I said that. Next one, number 21. Number 21, it says previously you learned that in a linear function, a constant change in x corresponds to a constant change in y. How is this related to slope? What are you looking for?
I'm gonna write that one on there because I
Too late. Okay. Previously you learned in a linear function, so we're saying basically we learned that if you have ordered pairs that are like this, okay, that I have a constant, if I have a constant change in x, and a constant change in y, that's a linear function. Well, the constant change in x, excuse me, the constant change in y over the constant change in x is your slope. So that's how they relate. The constant change in y divided by the constant change in x is the slope. So that's how it's related. Okay, it's that ratio of constant change in y to constant change in x. On number 23, it says most staircases in use today have a 9-inch treads and 8.5-inch risers. Okay, the tread, think about like don't tread on me. The tread is the part you step on. Okay, 9-inch treads. 8.5-inch risers, that's the rise that's going up. So that's 8.5 inches. Or you could think of it as 8.5. So that's basically, we're talking about a line with this as my horizontal change is 9 inches and my vertical change would be 8.5 inches. So if we're wanting to find the slope, where are we? We're just going to put 9 over 8.5. Now remember, you can't leave a decimal in a fraction. So, oh, I'm sorry. Yes, it is. Thank you. I was thinking about the number. Yes, sorry. 8.5 goes on top. You're exactly right. Over 9, and we can't leave a decimal in a slope. I mean, a decimal in a fraction. So I would move the decimal out of both the top and the bottom, and that would give me 17/18, I believe. And that would be my slope. Okay. Next, we have number 25. Why will the slope of any horizontal line be 0? Why will the slope of any vertical line be undefined? We kind of touched on this yesterday. If the slope, we did. If the slope formula is the change in y over the change in x, or the difference between any two y's divided by the difference between their corresponding x values, that's what slope is. Okay, a horizontal line, any 2 points on here, I'm moving left and right to go between them, which means the x changes, but the y does not. So the change in y here is totally 0. There's no change in y. If I picked 2 points and subtracted, they would have the same y value, like maybe 2, 3, and 6, 3. Those could be 2 points on a horizontal line. Okay, so the change between the y values on a horizontal line is 0. So that means change in y over change in x becomes 0 over whatever the change is between the x's. If you have a fraction with 0 as the numerator, that means 0. On a vertical line, it's going up and down. So it's not moving to the left and right at all. So that means there's going to be no change in the x values. This is why vertical lines have equation x equals some number. Like this could be the line x equals 2, which would mean it would have points on it like 2, 7 and 2, -1. There's a difference between the y values, but there is no difference between the x values on a vertical line. So if the change in x is 0, then regardless of what the change in y is, I'm going to have 0 in the denominator. 0 in the denominator is not allowed. That's undefined. A fraction with 0 in the denominator, we just say undefined. It doesn't exist, basically. Okay? We can also say, we also sometimes call that no slope. There is no slope there. We would not call 0 no slope because 0 is a number. That's a slope. That's a value. Questions on that one? That was number 25. Okay. Number 27, is that up there? No. Okay. Which one? Did somebody just say 10? 13 we did. Okay.
My bad.
Cameron, what do you want to see?
I was going to say number 27.
Awesome. All right. Number 27. The graph shows the number of files scanned by computer virus detection program over time. Estimate the coordinates of point A. Okay. I would say point A looks like it's at 16. Hang on a second. Yeah, 420 works. That's fine. And estimate the coordinates of point B. I would say point B is at 26, and I'd go a little higher than that, 640. Okay. Part C says use your answers from parts A and B to estimate the rate and change in files per second between points A and B. So part C, we're finding basically the slope. So we've got 640 minus 420 over 26 minus 16. And so then whatever you got for these two, you're subtracting your y's over subtracting your x's, and you get a different answer than I would necessarily. And that was it in terms of questions for these. Go ahead, I'm sorry. Okay, 1 second. Let me jump to that. This is on the second page, number 23. This is on page 268. It's at the bottom of the page down here and has a little graph. And it says, the graph shows the distance traveled by two cars, which car is going faster, how much faster, etc. So it has car 1 and car 2. I'd really like for y'all to stop talking. Which car is going faster? The speed is your rate of change. Okay? Rate of change is slope. So we'd be looking for a steeper slope. So steeper slope means faster. So car 1 is going faster. In order to tell how much faster, I would have to find the slope. Looks to me like the slope for car 1 is 60 and the slope for car 2 is 40. It goes up 60 for one unit horizontal change, and car 2 goes up 40 when it goes over 1 to the right. So car 1 has a slope of 60, car 2 has a slope of 40, so those are the speeds. So car 1 is going 20 miles per hour faster than car 2. How are the speeds related to the slope? The speeds are the rate of change in 1 hour increments, like what your slope is per 1 hour. Miles per hour is the slope for going from any point to the next point that's 1 hour away from it, basically. At what rate is the distance between the cars changing? That's interesting. Let's see. Yeah, I would say at 20 miles an hour because the change is 20. The difference between them is 20 miles an hour. So the difference between them is going to be changing at 20 miles an hour. After 1 hour, there's 20 miles between them. After 2 hours, you would expect there to be how much? 40 miles between them. And then after 3 hours, 60 miles between them, etc. Okay? So those are the questions we needed today on homework. Hopefully they are the same for you. If not, that still should have given you some insight.